In this video, we will study the design principle for shell and tube heat exchangers. The simplest shell and tube heat exchanger just consists of two concentric tubes. The shell side medium flows between the inner tube and the outer shell. The tube side medium flows on the inside of the inner tube. Rather than having only one inner tube, a shell and tube heat exchanger typically has a tube bundle consisting of several tubes. At each end, the tubes are welded to metal plates with holes for each tube. These metal plates, together with the outer wall of the tubes and the walls of this outer cylinder, constitute the boundaries for the shell side of the shell and tube heat exchanger. The medium on the shell side enters up here on the right and then flows through the heat exchanger once. We say that there is one passage on the shell side. Now, if we designed the shell side like this, the shell side medium would be mostly in contact with the outmost tubes in the tube bundle and hardly reach the innermost tubes at all. To force the flow in between the tubes, we add so-called baffles that force the flow to meander up and down along the heat exchanger. If we now look on the tube side, we have to add two end pieces to distribute the flow between all the tubes. In this example, we have the inflow on one side of the equipment and the outflow on the other. If we make the outer shell and tubes invisible, we see that the two end pieces look a bit like two empty cups. On the side where the tube side media enters, the purpose of the end piece is to distribute the flow into all the tubes. At the other end, the purpose of the end piece is to collect the flow coming out of all the tubes and let it out. With this design, we have the tube side medium coming in at one end and flowing along the heat exchanger once. Thus, we have one passage on the tube side. As we have one passage on the shell side and one passage on the tube side, we call this a 1-1 shell and tube heat exchanger. However, heat transfer takes time, and we might need to make the heat exchanger very long to fulfill our requirements. To make the heat exchanger shorter, so that it, for example, fits better where we want to place it and to make it easier to handle, we can let the tube side have two or more passages. Here is an example with two passages. Both the inflow and the outflow are now connected on the same side of the equipment. The end piece where the inflow and outflow are connected has a dividing wall, a so-called pass partition, such that the tube side medium flows to the right in the tubes in the lower part of the tube bundle and back to the left in the tubes in the upper part of the tube bundle. As we now have one passage on the shell side and two passages on the tube side, we call this a 1-2 shell and tube heat exchanger. I hope you now have a basic understanding of shell and tube heat exchanger design. I recommend you to test your own understanding by answering the following two questions. 1. Can you set up a 1-1 shell and tube heat exchanger so that the flow is counter current? 2. Can you set up a 1-2 shell and tube heat exchanger so that the flow is counter current? When you have tried to answer these questions on your own, take a look at the theoretical correction factors in our department handbook.